Okay, so even though today won't be like an official review, it's kind of like a review because this practice day gives us a pretty good overview of what all we covered in Unit 6. So let's just jump on into it. Since there is a practice day, there won't be any guided practice. Think of this as your guided practice. Okay, so for the first three, we have to say whether it's a polygon, and if it is, name it by its number of sides. So for the first one, this is a polygon. So we would say yes, or polygon. I can get my board to work. Okay, now we're cooking. So this is a polygon. Then we've got to count how many sides it has. It's got 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. The next one, it's not because we have two curved sides. So this is not a polygon. And then number 3, we've got all straight sides. They're all enclosed. So we're good here. This is a polygon. And then now we've got to count our sides. We've got to do so carefully. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This polygon has 12 sides. A 12-sided polygon is called a dodecagon. Dodecagon. Okay, for the next 3, we have to say whether they're regular or irregular, and then concave or convex. Regular means all sides are the same, all angles are the same. Concave or convex means it's either caved in or not. So if we look at number 4, I see 2 different types of dashes, tick marks. That tells me those are not the same. So I can, as far as regular or irregular, I can stop right there and say irregular. And then it looks like it's kind of pushed in right here. It's caved in. So this is concave. On number 5, all sides look to be the same. All angles look to be the same. So this one's regular. And any regular polygon is automatically convex. Number 6, all angles are the same, all sides are the same. So this is regular. And again, I just said it, all regular polygons have to be convex. Okay, so for 7, they ask us for the sum of the interior angles. That's the one where we have to use the formula n minus 2 times 180. So for a dodecagon, there are 12 sides in a dodecagon. So I would do 12 minus 2 times 180. That would get me 1800 degrees. And we have a nonagon. There are 9 sides in a nonagon. So we do 9 minus 2 times 180. That would be 1260 degrees. Now, number 8 asks us for what is the measure of each interior angle. So each interior. So we have to use our n minus 2 times 180 formula, but then we've got to divide by how many sides it has. So for instance, for a heptagon has 7 sides. So I need to do 7 minus 2 times 180, which will get me 900. But then I have to divide 900 by 7, which when rounded gets me 129. Then we have a pentagon. Pentagon has 5 sides. So we got to do 5 minus 2 times 180. So that will get me 540. But that's not enough. Then I've got to do 540 divided by 5 to get 108 degrees. Okay, next one. They ask for the sum of the exterior angles. So on the exterior angles, they always sum to 360 degrees. no matter how many sides there are, they sum to 360 degrees. For good measure, we'll say how many sides, but the answer is always going to be the same, 360. So for a decagon, there are 10 sides of the decagon, but the sum is 360. For a quadrilateral, there are 4 sides in the quadrilateral, but still the sum is 360 degrees. Okay, number 10, what's the measure of each exterior angle of the polygon? We want each exterior. So we're going to have to do 360 divided by however many sides it has. So a triangle has 3 sides. So that means I just do 360 divided by 3, which gets me 120 degrees. A 20gon has 20 sides. So I do 360 divided by 20. And that gets me 18 degrees. Okay, number 11, they ask us to find the value of z. Well, what kind of angles are all of these that they give us? These are all exterior, and what do all exterior angles have to add to? 360. So we can set up our equation by just adding them all up and setting them equal to just that, 360. 8z plus 7z plus 11z plus 14z equals 360. You combine all your z's together, you'll get 40z divide by 40, and you'll get z equals 9. Now the problem just asked us to find z, so we're done. Okay, number 12. It says MNOP is a parallelogram and MNO is 99 degrees. MNO, so this whole angle right here, this whole angle is 99 degrees. Well, if we think for our parallelogram properties, that means this whole angle is going to have to be 99 degrees. That whole angle is going to have to be 99 degrees. And then we can even go so far as to, just with that information, jump on in and get these two angles. Because on a parallelogram, consecutive angles have to be supplementary. So to get these two angles, I can just subtract 99 from 180. So 180 minus 99 can get me 81. So these angles are 81 degrees. I bet that's the angles they ask us for. Let's see. It says the measure of angle MPO. So this green angle down here, we said that was 99 degrees. The measure of angle NOP, we already said that was 81 degrees. And the measure of angle NMP, so M is where it turns, that one's 81 degrees. Now we've got to just find X and N. Well, let's do N first. So I know, since it's a parallelogram, I know my diagonals have to bisect each other. So that means to get N, I can just set 2n minus equal to n plus 2. Going to subtract n. It's going to be n minus 1 equals 2. Add 1, and I get n equals 3. Well, there's my n. N is 3. Then I've got to get x. So for x, well, we know sides have to be congruent. So I can set these equal to each other. 6x minus 10 equals 3x plus 8. Subtract 3x. I'm going to get 3x minus 10 equals 8. Add 10. I get 3x equals 18. Divide by 3, and we get x equals 6. So there's my x. X is 6. So we found everything it asked us for. Okay, on to the back. So at first, they're just telling us the different types of properties. This isn't a question. This is a reminder of the situations that we have a parallelogram. So first, we have opposite sides parallel. If that happens, we have a parallelogram. Then we have one set of opposite sides parallel and congruent. Next one, we have just opposite sides are congruent. This next one, opposite angles are congruent. This bottom one here, we have diagonals bisect. And this top one here, we have consecutive angles, supplementary. So these are the 6 occurrences where if this happens, you're guaranteed to have a parallelogram. So we did this Venn diagram on day 4, Unit 6, day 4, but let's do it again, just to kind of recall the properties. So, of course, the whole big box is quadrilaterals. So I'm going to write that down here. These are all quadrilaterals. Now, the main type of quadrilateral we talked about was a parallelogram. And within those, we had a rectangle, we had a rhombus, but then a square was here in the middle. It's a rectangle, it's a rhombus, it's a parallelogram, it's a square. It's a bird, it's a plane, no, it's Superman. Then out here all alone, we have kites. He's all lonesome. And then here we have a trapezoid. And this one has a friend. Well, it's not even a friend, it's a relative. It's an isosceles trapezoid. It's more than a friend, it's family. So those may help you understand the properties. Squares, rectangle, and rhombi all have the properties of a parallelogram because they are parallelograms. Then they each have their own properties. Kites do their own thing, trapezoids do their own thing. So, okay, 13, they ask us to find what SA is equal to. So SA is this segment right here. It's a rectangle, which means it's a parallelogram, which means diagonals bisect. So SA has to be 3.2. Don't make it complicated. It's really that simple. Okay, 14, what's BD? So BD would be this segment right here. Now, all sides of a square are 3, of this square at least are 3. So if we recall, on a square, we have a 45, 45, 90 special right triangle. So if we label our template X has to be 3. So our hypotenuse BD would have to be 3 square roots of 2. That's exactly what BD is. BD is 3 square roots of 2. Okay, number 15. 15 asks us to find RS. So we're finding this side right here. But notice, this line right here is called a mid-segment. And we learned a special formula for mid-segments. We learned that a mid-segment is essentially the average of the two bases. Base 1 plus base 2 divided by 2. So I don't know what RS is. I'm just going to call it X. So if I set up my formula, I'm going to have 25 equals X plus 41 divided by 2. I don't like fractions. I know you don't either. So multiply both sides by 2. 2 times 25 is 50. So I'm going to have 50 equals X plus 41. Subtract 41. And we get 9 equals X. So that means RS is equal to 9. Okay, 16. We have the same story. XY is our mid-segment. So we need to solve for n. That's what it tells us to do. Find n. Well, I know that n will equal 18 plus 26 divided by 2. So that gives me n equals 22. So you add these together, you get 44 over 2. 44 divided by 2 is 22. Okay, next one. So for the last 5, we have to find the numbered angles on each of these quadrilaterals. So remember what I said when we started solving these. Let's just find all the angles, then go back and we can pick out the numbered ones. So they tell me this one's 35 by P. Well, I know that's 35. This is 35. And this one's 35. Now I also know that around P, I've got me a right angle here. So to get the other part of this angle, I know part of it's 35. I can do 90 minus 35. That gives me 55. So this angle is 55 degrees. This angle is 55 degrees. 55 degrees. 55 degrees. Now it looks like we're left with just angles 1 and 4. I'm going to try to find angle 4 first. So I need to focus on just this bottom triangle. That's it. So for that one, I'm going to do 35 plus 35 to get me 70. Subtract 70 from 180. That gets me 110. So angle 4 is 110 degrees. That one's 110. Now these are on a line together, so they have to still equal 180, which means one is 70 degrees. So now let's write out what all of our angles are. They ask us to find 5 angles, so let's make sure we name them all. Measure of angle 1, 70 degrees. Measure of angle 2, 35 degrees. Measure of angle 3 is also 35 degrees. The measure of angle 4, and that's 110 degrees. And the measure of angle 5, well, that one is 55 degrees. There's our full complete answer. Okay, so 18. They tell us that angle GKJ, so this whole angle right here, is 102 degrees. We have to find angle 1 out there. Well, they tell me it's a rhombus right here. So that means these angles are bisected by the diagonal. So if I come up here and I do over here and do 102 divided by 2, it's going to get me 51. So this piece is 51, that's 51, that's 51, and that's 51. So what's the measure of angle 1? The measure of angle 1 is 51 degrees. Okay, for a square. I already kind of gave us one little hint earlier. I said that these angles, these smaller angles right here, are 45. So all of these are 45. 45, 45, 45, 45, 45, 45. All of these right here are 45. Now, since a square is also a rhombus, that means the diagonals intersect at 90-degree angles. So 90, 90, 90, 90. They're all 90 in the middle. So we found all the angles. It was that quick. So the measure of angle 1 is 90 degrees. The measure of angle 2, also 90 degrees. The measure of angle 3, 45 degrees. Measure of angle 4, 45 degrees. And the measure of angle 5, 45 degrees. There they are in all their glory. Okay, next one we have a kite. Well, on the diagonals on this kite, they intersect at a 90-degree angle. So I'm given 25, and yes, you can go on and say, oh yeah, this one's 25 too. That's great. You're right. So let's see if we can use the information that we know to quickly get angle 1. Angle 1's up here in this corner. Well, I know that one's 25, that one's 90. So let's do 90 plus 25. Gets us 115. And then subtract 115 from 180. And that'll get us 65 degrees. So, in conclusion, that means the measure of angle 1 is 65 degrees. Now, for this isosceles trapezoid, it may have disappeared on us, or it may not have been there to begin with. But yeah, I don't see a numbered angle. So what we can do is just do all the angles. I'm just trying to see if there's a number hidden somewhere. Well, let's undo that. Okay, no number hidden anywhere. Let's just find all the angles. It's not gonna be too bad. So B right here has to be 125 because this is an isosceles trapezoid. Base angles are the same. So B needs to be 125. Now, how do I get C and D? Well, together, B and C need to be 180. So I'm going to do 180 minus 125, which gets me 55 degrees. So C is 55 degrees. D is 55 degrees. I found all of them. Doesn't matter what number it asks for. I just found them all. Okay, so there is the practice day lesson in all of its glory. The assignment looks pretty similar to it, so get started on it.